Hello Algebra 2 classes. Today we're going to look at Section 2.2, Linear Relations and Functions. So a linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. The variables may not be multiplied together or appear in a denominator. A linear equation does not contain variables with exponents other than 1, and the graph of a linear equation is always a line. A linear function is a function with ordered pairs that satisfy a linear equation. Any linear function can be written in the form f of x equals mx plus b, or y equals mx plus b. We can replace that, of course, where m and b are real numbers. If an equation is linear, you need only 2 points that satisfy the equation in order to graph the equation. One way is to find the x-intercept and the y-intercept and connect these 2 points with a line. So for example 1, we'll go ahead and take a look. It says, is f of x equals 0.2 minus x over 5 a linear function? And then explain. The answer to this question is yes, it is a linear function. And the reason is because it can be written in the form y equals, and it actually does take the shape of mx, so negative 1/5 is your mx, and then plus 0.2, this being the b value. If I were to graph this, it would in fact be a line. Example 2. Is 2x plus xy minus 3y equals 0 a linear function? And then explain. Well, in this case, they say no. And the reason is that it is not linear because the variables x and y are multiplied together in the middle term. So when we see two variables being multiplied, that means that, no, it's not a function or a linear function. Now we will be mindful, I'm going to go back to variables may not be multiplied together or appear in a denominator. On example 2, that first part was basically what we were seeing, in that the variables were being multiplied. And when they are, we say that it's not a function. And later we may see problems where the denominator has a variable in it, and that would be not a function or linear function as well. Exercises. So it says, state whether each equation or function is a linear function. Write yes or no. So in looking at number 1, I've got 6y minus x equals 7. So I'm going to go ahead and attempt to get y by itself, really keeping in mind my goal. One of my biggest goals is to have it look like this. Now if I can't get it to look like this, y equals mx plus b, then we'll say not linear. Alright, so I'll take this equation and subtract 6y or add x. I'm going to go ahead and add x to both sides. That's our best bet because it's already negative x. If I add x, I have that 6y equals x plus 7. Then if I divide by 6, I'll have y equals 1/6 x plus 7/6. This equation is in fact y equals mx plus b, and even though we have fractions for m and b, that's totally fine. It's acceptable. Let's move on to another question. We'll go ahead and take a look at number 2. Number 2, 9x equals 18y. So again, I'm going to go ahead and attempt to get y by itself. And the way that I can do that is by cross multiplying, or simply just multiply both sides by y. If I multiply both sides by y, I'll have 9xy equals 18. And if I want to get y by itself now, I just simply divide both sides by 9x. And then what we'll have is y equals 18/9, which we know is 2. We'll have y equals 2 over x. So that clearly has a variable in the denominator. And we can then say, well, no, this is not a linear function. We may later say, and look at these types of things and say that they are still a function, but it's just not linear. And the last problem I didn't say yes, but we can actually write that too. But yes, it was linear. Okay. Next question. I'm going to jump here to another problem, number 7. Now in this instance, they use f of x. F of x equals 4 minus x cubed, or y equals 4 minus x cubed. Now, this has a very similar setup in terms of the possibility of maybe a b value and even m if we were to look at the number in front here. One thing that we do need to keep in mind, though, is that our exponent in any linear function, our exponent must be 1. Because it's not 1, we can then say, well, it's not linear. Again, however, it turns out, as we'll see in chapters down the road, we'll see that it is in fact a function. It's just not going to be a line when we were to graph that, if we were to graph that. We'll do one more problem here on this side. We'll do number 9. And in looking at number 9, we see that we've got, 2yx minus y plus 2x. Attempting to get y by itself. Anytime you have more than one variable in a problem, and you're also trying to get, in this case, y by itself, let's just get y in at least those two terms on one side. As you can see, I've already subtracted 2x. And the next thing you're going to do is factor out a GCF of y, because they are, in fact, both in 2yx and negative 3y terms. So divide out the y, and you'll be left with 2x. Divide it out of here, and you'll be left with negative 3. So there's the next setup. Okay, and then from here, we'll go ahead and divide both sides by 2x minus 3. And if you do that, we'll be left with y equals what we want, but we'll have negative 2x over 2x minus 3. So, because we have a denominator with a variable, we say that no, this is not linear. Again, we may see that this is a function down the road when we graph and observe this type of setup, but it is certainly not linear. All right, let's flip it over to the next side. And as usual, when I leave questions blank, I expect those remaining questions to be done for homework, or at least in this case I do. Sometimes I don't completely have you finish it, but in this case I will. On the next side, we see standard form. The standard form of a linear equation is ax plus by equals c, where a, b, and c are integers whose greatest common factor is 1. So example 1, write each equation in standard form. Identify a, b, and c. So we see y equals 8x minus 5, and what they, as you can see here, they move the 8x over to the left simply by subtracting 8x. So you'll have negative 8x plus y equals negative 5. Your a is negative 8, your b is 1 in front of the y, and your c would be negative 5. Here's the deal. Our textbook does in fact want a to be 1. I'm not a huge stickler on that, but traditionally you do want a to be equal to 1. And if that's the case, simply divide or multiply, as they say, each side by a negative. So if you multiply by a negative, 8, this becomes a negative 1, and then this last term, this c value, becomes 5. So a is 8, b is negative 1, c is 5. Down the road, I will be more lenient in terms of what a can be. If, in fact, you leave a as negative 8, and the rest of the terms, as you see, 1 and negative 5 respectively, down the road I will be okay with that. Part B, 14x equals negative 7y plus 21. First up is, as you see, add 7y. So if you add 7y to both sides, you get this. 14x plus 7y equals 21. Now, because 14, 7, and 21 are all divisible by 7, we do want to divide both sides by 7. So it becomes 2x, 14 divided by 7 is 2, plus 1 or 1y, and then equals 3. So a is 2, b is 1, c is 3. That is something you do want to do on even problems down the road all the time, because it's more simplified and it's really just easier to work with. Example 2. Find the x-intercept and the y-intercept of the graph of 4x minus 5y equals 20, and then graph the equation. So to find the x-intercept, we always set the other variable equal to 0, in this case y. And we'll do the same thing with the y-intercept, but we'll set x equal to 0. So we have 4x minus 5y equals 20. We'll substitute 0 in for y, as you see, and that's just going to cross or cancel out. We divide both sides by 4, and we get x to be equal to 5. So 5 comma 0, just plot that point. They already have the graph there for you. And they say then, so the x-intercept is 5, and they say similarly, the y-intercept is -4. So what I'll do is I will take that extra step and show you how to get that. So when you plug in 0 for x, as you see it cancels, divide both sides by -5, so y would be -4. So -4 here, 0 technically, comma -4 would be the ordered pair. It is important that you understand that they are in fact ordered pairs. Exercises. Write each equation in standard form. Identify A, B, and C. So for problem number 1, we go ahead and see that 2x equals 4y minus 1. We can subtract 4y from both sides. I will write it though so that ax is first, then by, and then on the other side, of course, c. So ax, in this case, 2x, so a is 2. B is -4, and c is -1. I can't divide 2, -4, and -1 by a common factor, so that's a perfectly good final answer. Let's go ahead and take a look at number 2. Number 2, I can really do one of two things. I can subtract 2x, or I can subtract 5y, but also subtract -3 in the same step. I'm going to do that. I'm going to subtract 5y. I'm going to subtract 3. Again, if you're wondering here what's going to happen, well, we'll have -3 equals 2x minus 5y. And as you can tell, my a value is in fact positive instead of negative. If it wasn't positive, in other words, if we subtracted 2x and left it as -2x plus 5y equals 3, I would be okay with that, but technically, according to our textbook, we do want the a to be positive. So we'll try to do that the best we can at the beginning of all this. A, B, and C are pretty clear, I would hope, in that a is 2, B is -5, and C is -3. And we don't have any common factors either to divide out. The next problem I want to take a look at number 7. Number 7, we can see we've got a is 0.4, not an integer, 3 and 10. B is 3, C is 10. So what I'm going to do is I'm going to first note that 0.4 is really just 4/10, and 4/10 as a fraction. Right? We can divide it by 2 and by 2, so we got 2/5. This is still 3y equals 10. So what I'm going to do is I'm going to multiply. It's a trick that I've done in the past. Multiply both sides by the denominator. Now, if we happen to have more than one fraction, we'll multiply by the value that's largest, or that really is the LCD, if you think about it. In this case, 5 is what we want to multiply by. So when we multiply 5 times 2/5, that becomes just 2. When we multiply 5 times 3, we get 15. And 5 times 10, 50. Okay. Taking a look at 2, 15, and 50, we can't divide by a common factor. And it works out perfectly in that we've got our final answer, as you see there, as my standard form. My A is 2, my B is 15, and my C is 50. We're going to finish up strong here with a graph problem. We're going to find the x and y intercept of the graph of each equation. Number 10 is perfect. We'll go ahead and set 2x plus 7 times 0 equals 14. This cancels. 2x equals 14, so x equals 7. We'll do the same thing with, and I'll just simply say 7y equals 14 and make our work a little bit quicker. And I'll just say y equals 2. So 1, 2, 3, 4, 5, 6, 7, comma 0, and 1, 2, so 0, comma 2. We've now plotted our x and y intercepts, and we can graph our line. This concludes section 2.2. Please finish the remainder of the problems on both sides of this worksheet for homework.